Good morning. My name is Jafar and our project is about Intelli and these are my team members. She's Sumana, Veena, Sumera. This is Arvind and Siddharth. So this is our project objective. Basically, when we consider our Indian farmers, they only know how the mechanism of irrigation will be working. They will go and on the motors and they want the pumps supplied from water pumps to be in their fields. So basically, what is the basic point over here is the farmers don't know whether the well is consisting of water or not. Irrespective of that condition, they keep their motors on running 24/7 whenever necessary. But the basic thing is, if there is lack of water in the wells, in such conditions, our motors get destroyed by getting wear and tear. All the parts in the motors get heated, and there are very high chances that the motor gets wear and tear. So as a result, again he has to buy a new motor, which costs him approximately some 4,000 to 5,000 or more than that. In such a way, he has to like efficiently. Every time he has to buy a new motor, which is very costly for farmers, for our Indian farmers. So basically, we have come up with the objective of overcoming this situation, and we actually are giving a suggestion with our prototype.
Today I'm going to say about the issues. So farmers significantly face the challenges with the water management and the irrigation, and they have to manually operate the water pumps and frequently check the water level in the wells and also monitor the soil moisture. And these all tasks are very time consuming and also inefficient, and the motors can also wear out due to the continuous use. So these all issues makes the farmers very difficult to manage the resources and to maintain the crop.
I'm Cmrcet. I'm going to say about existing systems. The first one is water pit. It's a device usually kept in the fields. It measures the soil moisture content of the soils at different levels depending on the bed of the soil, and it controls the irrigation of the fields as well. And now the second solution is CropX irrigation management system. It also measures the soil moisture content of the fields, but additional to it, it measures the temperature, the nutrient level of the soils, and recommends any measures to be taken by the farmers so that it yields into a better growth of crops. The third one is Senior Precision Agriculture. Here is a device usually hang outside near the fields. It measures the weather conditions and the temperature and when it will rain and all. It sends these data into a cloud-based system, and here, depending on the cloud-based analysis is taken care, and it recommends the farmers about what measures should be taken so that we can prevent any damage to crops. The fourth one is automatic pump controllers. Here, it's used for pumping of the water from the well. Here, depending on certain conditions, that is water level in the well, the pumping of the water takes place.
There are gaps in existing system. Many existing systems are too expensive for the farmers, for small scale farmers, and some of the solutions are too complex for the farmers with limited technical skills, and it's challenging to integrate the system with the existing farm equipment. The regular upkeep of this hardware may add to operational cost and complexity.
Good morning, my name is Arvind. I'm going to speak about user requirements. In this, we are using soil moisture sensor. It is used to read the soil moisture from the farm. Next one is float sensor. It indicates the water level in the well, and motor. It is used to pump the water from the well. And we are using ESP32 microcontroller. We can control these all soil moisture float sensor with this ESP32. We can ESP32 is also used for Wi-Fi integrated things. Next, we are using Blink interface. These readings are updated in Blink interface.
This is Siddharth. Before my friend explained about what are the components we have used in our project, now I will say that how it is integrated. Soil moisture sensor is connected to the ESP32 for collecting the data from this field and sending data to the Blink software. And here we are using a float sensor to detect the water level in a well, which gives the water present in the well or not to the farmer. Like coming to the working of our project, when water present in a well, the motor gets on and it checks the two conditions, like from
the water present in well or not, and the soil moisture range in the soil. When the soil moisture range is less than like 0 to 20 and the water present in the well, the motor gets on and it indicates to the farmer that the motor is in working condition. When the water exhausted from the well, the motor gets automatically off and it intimates to the farmer that there is no, it reaches its limit. And coming to the soil moisture mechanism, when soil moisture range from 20 to 100, it's saying that the soil consists of enough moisture content in that, so the motor will turn off. Thank you.